Yeah, I would say the main thing that we strive to do is to develop new tools, new ways of measuring and monitoring snow and ice on the Earth, and then using those tools to answer science questions. One of the challenges with measuring and monitoring and understanding the cryosphere is it changes over really short time scales. And so that requires sophisticated techniques to really understand how those properties vary across the landscape. So we have to use modeling and remote sensing to get to those kinds of scales, but we always have to be calibrating and validating our estimates from models and remote sensing using field-based measurements. And so the goal of trying to understand the cryosphere involves kind of those three main components. So a modeling component, a remote sensing component, and then a boots on the ground, kind of what we would call in situ measurements, or measurements that are made like in the environment.
I have done research. Mostly I started off in Greenland and looking at the glaciers that flow out into the ocean. These are called marine terminating glaciers, and seeing how quickly they're changing. They are the largest contributors to sea level rise. So glaciers in Greenland and Antarctica that go out into the ocean, they're getting smaller really quickly. I have a student that's working on Greenland, and he is looking at how quickly these glaciers that go into the ocean, how quickly they're pumping out icebergs. So icebergs are just chunks that break off from the glaciers. So he's looking at that, and then how quickly the icebergs melt. So we're curious not only how much ice is going from the ice sheet out into the ocean, because that's fresh water, but also when and where it gets to the ocean, because that can affect ocean circulation, and ocean circulation controls the heat budget for the Earth. So it really strongly controls our climate. So we're trying to figure that out a little bit better. I've had projects that have gone, that have looked at icebergs and glaciers in Antarctica. I've also, now I just got a project funded to look at glaciers in high mountain Asia. And so we'll also be looking at these surging glaciers in that area too.
I'm Coleman. I'm one of HP's grad students, Master of Science in Geophysics. We're out here today doing our first snow pit of the year. And so what that entails is identifying all of the different layers in the snowpacks and then recording different characteristics about each layer. So we'll look at the grain size, the grain type, and then the hand hardness. And then after we do that, we'll take a density measurement that gives us an idea of about how much water is in the snowpack. And then the last measurement we'll take is called a ram penetrometer that'll produce a hardness profile, and that gives us an idea of the difficulty to penetrate through the snow at any given depth.
This is something that gives people water to drink. Imagine if we don't prepare ahead for not having that kind of resources. It could result in water scarcity, and water scarcity can lead to a lot of disasters that we don't want. So preparing ahead is what we do. We try to tell the water managers the amount of water they should expect, and with that they can distribute it optimally to the people.